Hey everyone, just give me a second. Play from current slide. Right, Newton's second law of motion. Force equals mass multiplied by acceleration. F equals ma. The net force on an object is equal to the product, that means multiplied, of its mass and its acceleration, or F equals ma. Okay, now the units we use. The mass is measured in kilograms. That's the standard unit. Acceleration is in meters per second, which we can also write, like here, as meters per second minus 2. And then that should be on the next line, sorry. Force we measure in newtons, in respect of Newton, and it's given the symbol big N. 1 Newton is equal to the force required to accelerate 1 kilogram of mass, so think of a litre of milk, that's a kilogram, at 1 metre per second. So F equals ma. Let's do some maths. How much force, so we're looking for F, how much force is needed to accelerate 1,400 kilograms, so that's a mass, 1,400 kilometres, 2 metres per second. 2 metres per second squared, that's acceleration. Okay, so your first step, write the formula. F equals ma. Ta-da! Second step, put in the numbers and the units. So, we know mass, 1,400 kilos. We know acceleration, 2 metres per second. And then we just do the math. Solve. So, we go 1,400 multiplied by 2 gives us 2,800 kilograms per metre second squared. 2,800 newtons. That's the answer. Okay. If we have a look at this table here, let's look at across it. So we've got force equals mass multiplied by acceleration. So we've got 10. Now, does that equal 2 times 5? Yes, it does. That one is correct. Force is 10. It takes 10 newtons of force to move 2 kilos at 5 meters per second. It takes 20 newtons of force to move, where's my point about it? Equals 2 kilograms times 10 meters per second squared. I've got a gap down here. We've got to work out what this one is. So 20 equals what times 5? 20 equals 4 times 5. So the answer that you need to write in here is 4. Next one down, 10 equals 5 times something. What's the gap? 5 times what equals 10? It's 2. 5 times 2 is 10. Now for the last one, we've got to find this one. We've got a missing spot here. We want to find the force. What equals 1 times 10? It's 10. This is 10. 10 equals 1 times 10. Okay? So, there's a little bit down the bottom that you can't read. If the mass stays constant, oh, you can't see that, like this, if it stays the same, then doubling this number here, doubling the acceleration, doubles the force. If the force remains constant, like here, doubling the mass halves the acceleration. Okay. Right, are we missing much from this one? Okay, so Newton's second law proves that different masses accelerate to Earth at the same rate, but they have different forces when they hit the Earth. So, if we look over here, we've got a big potato and a little potato. One potato is massive and weighs 10 kilos. The other one is still a big potato and weighs 1 kilo. So the acceleration is a constant due to gravity. It's 9.8 meters per second squared. 9.8 meters per second squared. That's the acceleration when you drop anything. If I drop and I will do it in class, I'll stand up on the table and I'll drop two things, and they hit the ground at the same time. Okay, acceleration due to gravity same. Doesn't matter how big the object is. I'm not lifting up any students and dropping them, by the way, just to show you. When an object is big or an object is small, they fall towards the earth with same acceleration. However, they're going to hit it with different force if we look here. So the big potato is going to hit with 98 newtons. The little potato, 9.8 newtons. Okay. So they've both got the same acceleration. They're both falling at the same rate, but because they're different sizes, they have different forces when they hit. Okay. I think something's supposed to happen. Apparently he thought of it when an apple fell on him. Yep, let's move on. Okay, so now we're just going to do a little bit of math here. I want you to pause the video and have a go at these. What acceleration will result when a 12 Newton net force, so that's F, equals a 3 kilogram object? So 12 equals 3 times what? It's 4. If it's a 6 kilogram object, 12 equals 6 times what? It's 2. Okay. A net force of 16 newtons causes a mass to accelerate at a rate of 5 meters per second. Determine the mass. You've got to use your calculator here. I'm not bringing up a calculator. It's 16 divided by 5, and then you get your answer. It doesn't have to be a whole number. Okay, how much force is needed to accelerate a 66 kilogram skier 1 meter per second per second? So we're looking for F. F equals mass, that's mass, times acceleration, that's that. It's 66. Okay, what is the force on a 10,000, that's not 10,000, that's 1,000. My eyes are going blurry. 1,000 kilogram elevator that is falling freely at 9.8 meters per second per second. That's falling at due to gravity. Okay, so F equals 1,000 times 9.8. Okay, let's look at the answers. They haven't had the second one up. Okay, you can do this. Okay, and just recall, you can unsee all of it. I'll read you the bottom bit. A force. A force is a push or a pull that causes an object to change its motion. So we've got gravity as a force, we've got electricity and static electricity. We've got the force of this one down here. You can't see the word, it's underneath your screen. It's magnetism. And then we've got this one here. We've got the basketball, the runner, and the cyclist. You can't see it, but it's friction. And friction is a force opposing motion. Okay, that's it. That one's a very long video.